Hello physical science students, we're on to chapter 10 on simple machines, and I just wanted to remind you that you can use these PowerPoints on the exam and just pull them right up, use them. You can even hit Control F and you can search for anything that you want. It says search in PowerPoint. I mean, you can search for lever and it comes right up. So you can use that to your advantage. And that'd be just something good for you to know. Anyway, I'm going to briefly go through this PowerPoint. I started on physics, classical versus modern physics. Classical developed long ago, like mechanics. Modern physics deals with Einstein stuff. Scalar vector quantities. Scalar just has a size, vector has magnitude and direction. For instance, time doesn't have a direction. You don't say, I'm going 10 seconds north. But you would say, when you have a velocity, I'm going 10 seconds north, or a force, I'm going 10 seconds, or 10 meters, I should say, meters per second. Or force, I'm pushing 10 newtons to the south, whatever. Distance and displacement, remember distance, you add them all up. Displacement, you get the change in position. So if for instance, you have Bob travels 4 meters to the north and then 3 meters to the east. His distance he traveled would be 7 meters. His displacement would be the change in position over time, which would end up being 5 meters northeast, if I did that correctly in my head. So anyway, use the Pythagorean theorem, 4 squared plus 3 squared equals 25. Square root of 25 is 5. And that's where we get vector addition, Pythagorean theorem, etc. Motion, dynamics, mechanics, all just different terms there. Starting 10.2, you have this formula, speed equals distance over time. So speed equals distance, 180, over time, 2 hours, 90 kilometers per hour. Velocity, velocity equals displacement over time. You also have Newton's law, force equals mass times acceleration. So unknown force equals mass multiplied by acceleration. In this case, 2,000 multiplied by 0.05. Let me do that because I'm not going to do it in my head. 2,000 times 0.05 is 100 newtons, and he's pushing it to eastward direction, so I would say 100 newtons to the east or to the right. Forces in nature. Sir Isaac Newton worked with forces, one of the greatest scientists who ever lived. Force is a push or a pull, not the Jedi ways. Without forces, we would be unable to do anything. Force that opposes motion is called friction. Gravity is affected by mass and distance, doubly affected by distance. There's a difference between mass and weight. Mass is the amount of matter in an object. Weight's the force of gravity on an object. We kind of use them interchangeably, but if you went to the moon, your weight would change, but your mass would not. It's more about the mass than the weight. Inertia is the tendency of an object to resist change in motion. Consider this GIF, where this guy drives into a wall. Not fun. He keeps going. Why? Because you resist a change in motion when you're going 70 miles an hour in your convertible. An example of inertia would be magician's trick of pulling out tablecloth from under dishes. You go, whoosh, dishes, stay there. Don't try that at home. Your mom might get angry. Machine does work. Mechanical advantage is distance in divided by distance out. We worked with pulleys on mechanical advantage, how you could sacrifice distance and speed for force. And so the pulley made it easier to pull the object, but it also took a whole lot longer and a whole lot more distance. There's Roy Halladay, a great pitcher. Actual mechanical advantage, kind of different, because the world slows things down through friction. You have 3 different types of levers, and that's about the end in PowerPoint. Let me know if you have any questions. Make sure you study hard for this exam coming up. I will see you guys later.